I thought I'd just go over this VESC. I've got hooked up on what I'm doing, what I'm using it for, but at the moment I've just hooked up to this alternator that I've converted into a brushless motor. I'm going to do a screen capture of the software that comes, or that you can download for the VESC. Banggood sent me this for review slash projects, further projects, but if you're messing around with any kind of brushless motor or plain brushed motor, these are great. You can change all the settings inside in the software, which I will show some of the ones that I'm playing with, and also you can see electrical RPMs. So this is a 6-pole motor. Well, it's actually a 12-pole motor, but 6 pairs. So that means that you would divide the electrical RPMs by 6, and that would give you the real RPM. I'm just going to verify that with the taco that I have here. I've got a little, put the reflective tape on the shaft, so to see if it is actually correct, and yeah, go from there. So plug it in. Also, I've got the field windings on a, what's it called, PWM controller. I'll just get the camera. So I've just got this PWM controller. I'll just set it on max for now, which would be about 12.3 volts, I think. Comes out of there. So there. Yeah, so I'll just show you guys what can be done. There's quite a few. Get quite a few RPMs out of it. It's actually quite scary to run it up. What I will do is, once it's running, I can check the volts of the PWM controller's putting out, so see what the field windings are at. So I'll do that once it's running. Anyway, what I do is I do a screen capture. So at the moment I've got it connected up to 10S batteries, a 10S LiPo battery. Just there. And let's get this rolling. Just wait for this to come on. Why is this not recording? Oh, yeah, there we go. Just wait till the computer starts recording. Right, it's recording. Okay, right, so we've got it on. Let's connect this. Invalid. Helps if we plug it in. That's it. There we go. Right, we're connected. So what I'm going to do is just start by going onto here, finding data sampling. So we're running at volts in 39.4 volts, and this is running at full, so this will be the 12 volts on the field windings. And that is saying just around 20,000 ERPM. It's 3,646 RPM. Now if we change the field windings and lower them down, that was 6,058 RPM, and ERPMs was, I'll find out what that was. That was 30,000. Should come a bit clearer in a minute. Yeah, so probably around. It doesn't give us a great explanation, but it's about. As it comes down, might be able to see the number. So we're at about 35,000 electrical RPMs. So if we do a quick calculation, get a calculator. So that was 35,000 electrical RPMs. Divide that by 6, 5,800. So yeah, there's a little bit under. So the tacho said, did it say 6,000? I can't even remember now. Better find out. Wait a minute. That went high. That's pretty scary. The motor was going to go, but you could probably go a bit higher to being a wuss. Anyway, I thought that's. I'll overlay the image of the capture on there, just show you. And I'm thinking about putting another motor on this board here, so on this metal plate, and then running a chain to it. So you can see how we can actually load the motor up and see how many amps it pulls and stuff, you know, just get a general idea. But that's with the brake on, so I can hardly turn that. And when I do turn it, the amps are increasing. So you can probably see it on the screen because I'll have the other one. So you get like 7 amps just by turning that. It's pretty good. And that's regenerative braking, which is putting power back to the battery. So it's going to be quite interesting once they're linked together to power one. So what my plan is to have 2 VESCs, one as the braking motor and one as the powering motor. Then obviously we can put different loads on it, so different amperage loads. I just need a way of. So obviously amps are just a reading. I don't know whether to do it in watt hours. That's going to be the actual working power. Obviously as volts change, you're going to get different amp changes. It's going to be really hard to keep a consistency, especially if I've got whatever power I've got powering the braking VESC. That's going to change amps in the software, so you're not going to get a really consistent result. But with watt hours, obviously you will. I just need to keep an eye on the RPM and how many amps it's creating at that RPM, and how many amps the motor is putting into creates that amount of amps at the RPM. That's probably where we're going to get the results, is the amps used to create the amps used and the amps, or the watt hours used to create the watt hours. So that gives us the actual result. But yeah, this, I thought I'd just give you a little rundown. I'll post another video as soon as I've got that done. Anyway, if you want one of these VESCs, just click on the link below and go through to Banggood and buy it. I've tortured this thing so far and it seems to hold up pretty good. I've had the motor doing some really weird things where it's well, I've sort of started it in reverse and it's started the wrong way and stuff, and that's just due to the setup. And yeah, it sounded really horrible, and I thought it was going to blow the VESC up, and I couldn't actually turn the motor off for a little while to unplug it. And the VESC didn't overheat and didn't even seem to harm it in any way. So also you got your VESC temperature, your FETs on there, the switching FETs. So that's pretty good to keep an eye on, and you can set all the temperatures as well. So if I go into here, you can go see the temperature it was running at. Obviously you've got your amps and stuff down the bottom here. And then if you want, you can see current, what current you're using, electrical RPMs. It also does FOC, which is actually quite good. So if you listen, listen how noisy it is. We quickly go to here, change to FOC, just write that data to the VESC, and go. Listen to that. Also the starting, let's have a look at the starting quickly. Go to BLC, there and there. How well, you can get these starting pretty well. Like that. So this is without Hall sensors, so that's a pretty slow RPM for without Hall sensors. So that is 36 RPM. So that's pretty good. So that's this limit. I could probably change that and get that lower. But yeah, I can't stop it. It's going to slow. Oh, nearly. Yeah, be interesting. Alright, well, yeah. If you like the video, subscribe and press the like button, and I will get you some more videos soon as I get this other motor sorted. I'm not sure whether to run a brush motor because it's nice and simple, might keep some of it consistent, or I've got another, I'll just take the camera around, otherwise I've got another motor here which I've just got to turn, so I've just got the wires poking out. Got to run some more wires up, and I was thinking about running separate wires out of the cage, and then I could change between delta and the Y configuration, as a star configuration, and that way I could, you know, a lot more you can play with there. I can do it on that motor as well if I take it apart again. But yeah, all good. I'll see you in the next video.